Let's learn about work, huh? Okay, so draw in your notes, draw yourself a nice cylinder. I don't know how many cylinders you've drawn, you know, but there's, right? And then draw a piston like that, and show the piston moving up some distance. We'll call that distance S, to a new position. So it's expanding. It's increasing the volume of the cylinder, right? Yeah. And we could do this. You actually could do this if this is a frictionless cylinder and it also doesn't leak, you know. And we put just a weight on there, like a kilogram mass on there. The mass would not push the gas all the way down because it would push it down just far enough that, well, whatever, the pressure would be equal or something like that, right? It would stop compressing, it would just rest on there. And then if we stuck this over a burner, if we heated this up, yes? Okay, wouldn't it eventually expand that gas, lifting the mass? Wouldn't it? Wouldn't the pressure rise? Yeah, I'm thinking the pressure would rise, right? And in this case, we would actually get usable work out of the gas. Isn't that clever? That's where we're headed today, is how do you calculate that work? And then ultimately, I'm going to bring out the little steam engine. I've got a little steam engine that's going to take heat and turn it into work. I call it the little steam engine that could explode. Okay, so I know. So there it is. Well, it is. It's always an exciting thing, right? Okay, so there it is. It pushes this thing up, and the work that this does is very easy to calculate. It's just force times distance. But what's the force? Well, let's use this formula. Pressure is force divided by area. So therefore, what is force? I don't know. Go ask your pa. I don't know. I'll ask your pa. Okay, that wasn't very funny. Now, what I'm going to do is I'm going to substitute that in for the force, right? And we definitely should do that because you really don't want to pass on some opportunity to learn physics, right? Of course not, yeah. Okay, now take a look at the last half of that. Let's just look at it as I have written it on the board, right? Let's just look at that. That's area times S. Well, what is the area of this piston times the distance that it's traveled upward? What is the area of the top? Don't you see that there's a little volume there that is a right circular cylinder? I don't know that you have to say it's a cylinder, right? What is the area of the top times the height of it? That is the volume. In fact, in this case, it's the change in volume, isn't it? It's crazy. So A times S, this area times that S is delta V, delta volume, right? Okay. And so this, drum roll please, work is pressure, change in volume, da-da-da-da, 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 there it is, right? It's the work done by the gas. P is the pressure of the gas, and delta V is the change in volume. So this guy is going to be in cubic meters. This guy is going to be in newtons per square meter or pascals, right? Yeah, he's here. Jacob. Huh? I don't think she's bringing bad news. Bye-bye. Any last words? Okay, go ahead.
Question for you.
Yeah.
You nominate me for the class act thing? You got it. Yeah. You nominate me for that? Is that why you got jokes?
No.
Seriously, did you do
No, actually I didn't. That is sweet. Class act. I like how like everybody else is not quite as classy as the people that get called up there.
I thought for sure it was you. But don't be.
So anyway, this guy is going to be in cubic meters. This guy is pascals, right? And then for this delta V here, if it's an expansion, if it expands, that's a positive change in volume. If it's a compression, well then that's, compression means a negative change in volume. We're pushing the piston in, And this is what we expect, right? If the piston moved out, we've already done this, right? The piston moving out makes it positive work. Piston moving in is work on the gas, so it's negative work. Haven't we already done that? Yeah, we have. Okay. So work in this case is going to be actually joules, right? So let's hit the right arrow. Oh, I got an example, right? Let's do an isobaric compression at 500 pascals. So that looks like this. Okay, this is pressure and torr. If that's 1,000 torr, then this is 500, right? Okay, and then we go from, here is 1 cubic meter. Here's 0.85. So here I'm going to draw this on a PV diagram. There it is. There's this process on a PV diagram. What is let me make sure am I on there? Yes, I am, right? Okay. So first off, isn't our delta V negative? Yeah. We're going from 0.85 to 0.52, right? And so our delta V is going to be negative 0.33, is that right? And now we're all set. We can go. Work is 500 newtons per square meter, or pascals, right? Times negative 0.33. What happens to the units? What should we get? Should get Newton meters, should get joules, right? A Newton meter is a joule. What do we get? Well, meters squared cancels 2 of those, leaving, we get Newton meters, don't we? Joules. Yeah, so it is joules. And then this is, that's 150 plus 15, right? But it's negative, so it's negative 165 joules. Isn't that beautiful? So it's negative because it's compressing. It's negative because the delta V is negative when you put a negative in there. Pressures aren't negative, but the delta V could be when you put negative in there, you get negative, right? It's also negative because it's not work done by the gas, it's work done on the gas. So many ways that it could be negative. Yeah? There we go. Isn't that exciting? Are you excited by that? Do you want to try that yourself? Why, yes, you do.